So I'm going to start with FASTT, and FASTT, as you may notice, has two T's in FAST. And FAST is really an acronym for Fluency and Automaticity Through Systematic Teaching with Technology. And FAST is a program, as I said before, targeted to help students in grades 2 and up achieve math fact fluency. So what is math fact fluency? Math fact fluency really is comprised of two key pieces. We want students to be accurate with their basic math facts, addition, subtraction, multiplication, and division, but we also want them to have that speed, that automaticity. So with FAST, that's what we set out to do. And Dr. Ted Hasselbring really is the father of the FAST model. He's really been researching fact fluency since the 1980s, and he's really been a leader in adaptive technology and really how can we engage students and challenge them appropriately. If any of you are familiar with Scholastic's Read 180, Dr. Ted Hasselbring is in fact the father of Read 180 as well. So the FAST Math intervention model begins with an initial placement assessment. This initial placement assessment will diagnose which facts a student knows fluently and which facts a student still needs to learn. Those non-fluent facts, those facts they still need to learn, those will be targeted for adaptive instruction. And really, our goal with FAST Math is to move facts from working memory to long-term memory so that they can free up that working memory so that they can work on more complex tasks in mathematics. So as those non-fluent facts are going to be in adaptive instruction, and then the fluent facts, as well as the facts that the students have learned already, those are going to be targeted for independent practice. And that's where students are going to participate in a game like Atmosphere to really gain that speed. They've shown that they have the accuracy. Now we're going to work on their speed through games. Throughout the whole program, we're continuously assessing students to see how they're doing within the program. So I want to talk a little bit more about the placement assessment. The initial placement assessment is comprised of two parts. First, students will take a typing assessment. We're really going to calibrate a student's typing speed because we don't want to penalize any slow typists. What we do is we show numbers to students, say 24, 32, 16, and as these numbers come up on screen, students will type in the numbers, and we're going to record how long it takes those students to type in those numbers. The second part of the placement assessment is the math fact assessment, and this is where students we're seeing which facts they know fluently and which facts they still need to know, but we're also recording how long it takes the student to answer those math facts. This part is also adaptive, so as students who are, starting to struggle with, say, their 6s and their 7s, we're not going to challenge them with their 9s, 10s, and 11s because they've already shown that they can't really display mastery with those 6s. So this is adaptive in that sense. But what's really unique and smart about FAST Math is we take the amount of time it took a student to, say, type in the number 24, and the amount of time it took a student to answer the math fact 4 times 6. We subtract those 2 times, and we come up with a response latency for each math fact. So that's really how we determine whether a student is fluent in a fact or non-fluent in a fact. And a student is coined as fluent if they can answer that math fact in 0.8 seconds or less. After that initial placement assessment, this is what students will see, and this is Maria's fact tracker. It's really each student's personal GPS within the program. As you can see here, her FAST facts, those are highlighted in yellow, and the facts she still needs to learn are in blue. Okay, so students then, the facts that they don't know, they're going to be targeted for adaptive instruction. And this is really where they're going to make a memory connection to each fact. Students will be introduced to 2 to 3 facts in a daily session, and we're really doing, they're going to see the fact in a visual array or 10-frame grid, they're going to hear the fact, they're going to be encouraged to say the fact aloud, and then they're going to have to type out the entire number sentence from working memory. Again, this is really where we want students to build a memory connection to each fact. So I'm going to go ahead and show you a sample of adaptive instruction.
3 times 7 equals 21. 7 times 3 equals 21. Say these out loud to help you remember them. Click See It to see a display of each fact. When you can remember these facts and you're ready to practice them, click Go. 3 times 7 equals 21. Remember, this fact is the reverse of 7 times 3 equals 21. We can show this fact as 3 groups of 7, 1 group of 7, 2 groups of 7, 3 groups of 7, 7, 14, 21. Click Go to go back to your list of study facts for today.
Okay, so that gives you a sample of what that adaptive instruction looks like. The next screen that would come up is a blank screen similar to this one, but with boxes. And students would have to type out the entire number sentence from working memory. So they type out 3 times 7 equals 21, and 7 times 3 equals 21. The next piece of the adaptive instruction is we're utilizing expanding recall. And this is really helping to move the facts from working memory to long-term memory. And what we do is we gradually intersperse those new facts with the facts that the student has already coined or showed to be fluent in. So as you'll see in this animation that I'm about to show you is that these new facts, 3 times 7 and 7 times 3, are gradually interspersed with the facts they already know, and the goal is to stretch out the amount of time that that student needs to hold on to that fact in their working memory until eventually it gets into their long-term memory. So I'll show you a sample of the expanding recall model in the adaptive instruction portion. So as you may have seen, throughout this adaptive instruction, we're going to give students immediate corrective feedback if they get a fact incorrect, as well as you might have seen that clock show up. And that really was one of the students' facts that they're fluent in. And that clock popped up because we knew that that student either maybe was using an inefficient strategy, such as finger counting, because the goal, again, being is to give students that feedback they need, again, to try to get them to have 0.8 seconds or less to answer a math fact. So you also may have noticed that as students work through more and more facts, the amount of time they saw 3 times 7 and 7 times 3 got greater and greater. Okay, so students, they are introduced to 2 to 3 facts a day in adaptive instruction. They're going to utilize that expanding recall to move those facts from working memory to long-term memory. And then the 10 minutes is completed with an independent practice game. And again, Dr. Ted Hasselbring's research really shows that students achieve automaticity through practicing what they already know. So here in the game-like atmosphere, students are going to be practicing their learned facts and the facts that they're fluent in. This is really helping them, again, to build that speed. We have a variety of games within FASTT. Something a second grader would enjoy all the way up to something high schoolers would enjoy, and there's a variety of different games available to the students.